Welcome. In this module, we will explore the core compute options within Microsoft Azure, specifically focusing on virtual machines. We will examine what they are, how they are stored and secured, and the different ways you can deploy them to ensure scalability and availability. Let's start by defining what an Azure Virtual Machine, or VM, actually is. It is an infrastructure as a service, or IaaS, offering. This means Azure provides the hardware virtualization, but you are responsible for the operating system and everything that runs on top of it. This gives you total control over the environment. You can install your own web servers, databases, or custom scripts, exactly as you would on a physical server in your own data center. This flexibility makes VMs the perfect choice when you need to migrate specific workloads to the cloud without rewriting code, or when you need a sandbox for development and testing. This diagram illustrates the IaaS responsibility model. At the bottom, we have the physical hardware and hypervisor, which are managed by Azure. Sitting on top is the virtual machine. Everything inside the VM box, including the operating system and applications, is managed by you. This visualizes the boundary between the cloud provider's infrastructure and your responsibilities. When creating a VM, you must make several critical configuration decisions. First, you select an image. This is a template file containing the OS, such as Windows Server or Ubuntu Linux. Next, you choose the size. Azure offers various sizes optimized for different tasks. Some have more CPU cores for computation, while others have high memory for databases. Finally, you configure networking. A VM is a logical construct that includes network interface cards, or NIC, which connect to Azure virtual networks to allow communication with the internet or other internal resources. This mind map breaks down the essential components of VM configuration. The central node branches out to image, where you select your OS. The size branch defines your hardware specs, like CPU and RAM. The networking branch lists the connectivity components, like VNet and public IPs, required for the VM to communicate. A VM needs storage to function. In Azure, this is handled through managed disks. Every VM automatically comes with an OS disk, which is the bootable drive containing the operating system. For application data, you should attach separate data disks. You can choose the performance level of these disks based on your needs. Standard HDDs are cost-effective magnetic drives, while premium SSDs provide high-performance, low-latency storage backed by solid-state drives. Choosing the right disk type is crucial for balancing cost and performance. This block diagram shows how storage attaches to a VM. The VM compute unit on the left connects to multiple disks on the right. The OS disk is highlighted in blue as the primary boot drive, while the data disks are attached separately for storing your files and databases. To ensure your application stays online, Azure provides availability options. An availability set groups your VMs within a single data center, spreading them across different server racks, fault domains, to protect against power or hardware failures. For even greater protection, you can use availability zones. These are physically separate data centers within the same region, possessing independent power and cooling. Using these options increases the service level agreement, or SLA, ensuring your application remains accessible even during maintenance or outages. What if you need to manage many VMs at once? This is where Virtual Machine Scale Sets, or VMSS, come in. VMSS allows you to deploy a group of identical VMs that are automatically load balanced. The key feature here is auto-scaling. You can configure the system to automatically add more VMs when CPU usage is high and remove them when demand drops, ensuring you only pay for what you use. VMSS is the preferred way to build scalable compute clusters in Azure. This diagram shows a virtual machine scale set. A load balancer sits at the top, distributing traffic down to multiple VM instances contained within the scale set. This visualizes how VMSS treats multiple VMs as a single logical unit for easier management and scaling. Another specialized form of VM usage is Azure Virtual Desktop, or AVD. This is a desktop and app virtualization service that runs on the cloud. Instead of managing physical laptops for every employee, you provide them with a secure, virtual Windows desktop that they can access from anywhere. It supports multi-session Windows 10 and 11, allowing multiple users to share a single VM, which optimizes costs. It effectively streams the desktop experience to the user's local device over the internet. This sequence diagram shows the user experience in Azure Virtual Desktop. The user connects via a client app to the AVD gateway. The gateway brokers a secure connection to a session host, VM. Finally, the host streams the desktop interface back to the user, allowing them to work remotely. To summarize, Azure provides flexible virtual machine options to meet diverse needs. You use standard virtual machines when you need total control over the operating system and environment. You use virtual machine scale sets when you need to manage identical VMs that auto-scale with demand. You rely on availability zones and sets to protect against hardware failures. And finally, you use Azure Virtual Desktop to deliver secure remote work experiences. Our final mind map recaps the module. Single VMs are for control. Scale sets are for growth and scaling. Availability covers our redundancy strategies like zones and sets. AVD represents the specific use case for remote desktop virtualization.